So the slope is not going to change at all from x equals 1 to x equals 2. So we'll get something that looks like this. Now what I've really quickly created down here is a little table so that we're not having to actually plug in values into this equation and figure out all the y's and plot the individual y points. Again, we would get something slightly different than what we're seeing here because we're making some assumptions that aren't 100% accurate, but this allows us to think about slopes and what's happening to the slopes. So from x equals 0 to x equals 1, we have an initial rate of change of 2. We've demonstrated that by this line segment. From x equals 1 to x equals 2, since the slope is dropping by 2, we would now have a slope of 0 from x equals 1 to x equals 2. So that means I'm just going to draw a flat line segment that has slope of 0. Okay, from x equals 2 to x equals 3, the slope drops again by 2 units. But since it's already 0, now the slope becomes negative. So now it's a negative 2. It's headed in this direction. From 3 to 4, the slope gets 2 units smaller. So a slope of negative 2 minus 4 is now, or minus 2 is now a slope of negative 4. So it drops by more. It doesn't quite drop by just this amount. It drops by a lot more. So let's just say that it kind of looks like that, almost. So that's a bigger drop now. Here where there's a drop of 2, now there's a drop of about 4. Now again, we don't know exactly whether this is going to cross the horizontal axis between 3 and 4 because we're not being exact, but here's the pattern. What's happening? Well, the outputs begin to increase and then suddenly take a turn and begin to decrease. And notice that all we're really keeping track of is the slope itself. We know the initial value, we know where to start, we know the initial slope. To get from x equals 0 to x equals 1, we have a slope of positive 2. And then we just need to know what's happening to that slope. How is the rate of change varying? Well, the slope itself is dropping by 2, twice the value of a. And we can get a pretty good sketch. So what I'm going to do now is I'm going to pull up my calculator. So all I'm going to do is I'm going to plot this into my y equals screen. I'm going to remove all of these equations that I have plugged in, and I'll do negative x squared plus 2x plus 4. And I'm going to just do a standard zoom, so I'll do 6, just to kind of see what I see. And look at that. Lo and behold, in the first quadrant right here, we are seeing that same shape, that it looks like between 1 and 2 it flattens out, an input of 1 and 2 it flattens out, and then it comes back down, 1, 2, 3, and somewhere between 3 and 4 it does look like it crosses the horizontal axis. So we did a pretty good job, and we didn't even have to plug in x values into this. We just were able to think about it in terms of the rate of change. So let's see how we do on another one. So let's see here. Let me get to the right document. So next one, let's look at this guy where all the parameters are negative. And by parameters, I mean the values of a, b, and c. So here we have a value is negative 1. Put a 1 there. My b value is negative 2. And my c value is negative 4. So what do I know? Well, I'm going to start at negative 4. My initial rate of change is negative. So that means that initially my outputs are going to be going down. So from x equals 0 to x equals 1, I'm going to draw my table again, but I'm just going to focus on the slopes themselves to be able to get a good sketch. Whoops, this should just be the change in y. So when x is 0, it goes from 0 to 1, my initial rate of change is negative 2, so we have a drop. Twice my a value is negative 2, so my slope is going to be dropping by 2 units. So from an input of 1 to an input of 2, my slope will go from negative 2 to negative 4. So that means my slope will be steeper and will maybe look more like that. From 2 to 3, I'll have a slope of negative 6, so it'll get even steeper. And from 2 to 3, we'll have an even steeper drop. So we'll kind of experience something that looks like this and goes downwards and grows faster and faster in the negative direction. So that's kind of the insight behind doing this. And again, we don't have to do a lot of complex calculations. And just to verify really quickly, we'll plug this guy in. Negative x squared minus 2x minus 4 And let's